So let's hurry and make sure we're good with some of the simple trig identities. So it says verify that tangent x, cotangent x over cosine x equals secant x. So remember, you can't move from one side of the equation to the other. You take the ugly side, turn it into the pretty side. There are 10 ways, million different ways to do this. It just depends on how you decide to tackle it. So can anyone see something on how you'd start to simplify this one? Yes? Perfect. This is sine over cosine. This is cosine over sine. So wouldn't that cancel out to be 1? Yeah. Or even more easily, she was saying up here that we have actually tangent of x times 1 over tangent of x, since that's what cotangent of x is by definition. Which is tangent of x over, so this is what we're looking at. This is how you show your work on the exam. So then you'd say that's 1 over cosine of x. So Cameron, you would make sure to not on the test, just do it in your head, right? You'd show me sine over cosine over sine, because that's just what you have to do. Does that make sense? Don't do it in your head. Okay, awesome. And then from there we get, that's not simplified as it can be, because fractions are less simplified than no fractions. So that's secant x, everybody. Okay, make sure you know how to do trig identities, the basic stuff. All right, awesome. That's as hard as our trig identities are going to get for this exam. All right. So what we're doing today, guys, is we're going to be able to, we're going to be looking at trig functions from any angle. Now, here's the thing. Technically, this is no different than the lesson of if we have an entire unit circle, we can use this same idea, but we're going to pretend like we don't have a unit circle in front of us, and we're only going to focus in on quadrant 1. You're going to see how this is going to be really usable for us. So this is actually all stuff you already know. You don't even necessarily need to write it down. It already is what we know. Sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse, right? Tangent is opposite over adjacent. So look where this is coming from. Let's read this statement here. It says, let angle theta be an angle in standard position. Remember, standard position means on an XY chart, with an XY point on the terminal side of theta. So right here's my terminal side, correct? And on that terminal side, I have this XY point. Now it says our R will be the square root of x squared plus y squared, which can't be 0, which makes sense. Our radius can't be 0. So where are they even coming up with this? Well, let's make sense of it. Don't I know that I can drop straight down from that point right there, create a right triangle. Now, wasn't this an x amount of distance? And this is a y amount of distance. So now to find our radius, wouldn't we do x squared plus y squared equals hypotenuse radius squared? Solve for r. Square root both sides. Do you guys see how they're getting the r equals square root of x squared plus y squared? Yeah. So now it says we can use this idea. Well, where should I put my theta? Can you remember what we talked about? Closest to the origin and x-axis. So shouldn't I put my theta maybe right here? Yeah, now look, sine is opposite over hypotenuse. That's why they're getting y over r. Cosine is adjacent over hypotenuse. That's why it's x over r. Tangent is opposite over adjacent, right? Y over x. And then they're reciprocals. So we already know all that. We don't even need to write it down. Everybody good with that? Okay. Now what I did technically, guys, is I just did exactly what this lesson is going to talk to us about. I used what's called reference angle to draw in this orange theta. So instead of drawing in red theta, won't my orange theta have the same trig ratios as red theta? Yeah, it did, right? And that's called a reference angle. So let's talk about what a reference angle by definition is. So it says right here, a reference angle, red theta, let red theta be in standard position. Its reference angle will be the acute angle, orange theta, formed by the terminal side and the horizontal axis, or the x-axis. So that's exactly what we just did. We used the idea of a reference angle to have a right triangle so that I can do right triangle trig. Because the ratios of orange theta and red theta will be the same. So we always, wherever we're at, we always will drop right down to the x-axis, create a 90-degree triangle, and then our reference angle will always be positive. And then we will just have right triangle trig, no big deal. Yeah. Yep. One thing to know about a reference angle is a reference angle we always write as it's going to be an acute angle since it's in a right triangle every time. And every time it's going to be positive. We're going to write it as a positive angle. Okay, so watch how easy it is to use this idea to begin with. Okay, so let's kind of look at what I'm talking about. This is when this is going to be really useful for calculus. When we're dealing with angles that fall on the unit circle. So everybody right here, if we just know quadrant 1, we have enough, here's quadrant 1, we have enough information to answer trig of any angle that falls within that same 30-degree reference angle. So right here is, we know at 30 degrees, remember we're trying to get this memorized. This is really what I'm hoping you guys will get memorized, and it's going to really help you for next year. 30 degrees, the distance of 30 degrees will always have this XY point, right everyone? The distance of 30 degrees has that same XY point. The negatives and positives change depending on quadrant, but this will be our XY point. So 30 degrees has root 3 over 2, 1/2 as its XY point. Now, we would use this when, if I, now changing colors here to green, if I started here and I drew out to here, this angle, here's my new terminal side, instead of talking about 150 degrees, if we don't have the unit circle in front of us, what we're hoping you'll do is be able to say, well, that is a 30-degree right triangle, isn't it? Because it's down to a 180 degrees is a 30-degree distance. So then from there, you're going to use that idea. I know a 30-degree triangle would have this XY point, root 3 over 2, 1/2. And then you'd say, but this one's in quadrant 2, so it has a negative X. That way you don't have to have the whole unit circle in front of you. Do you guys see how that's kind of useful? Okay. Now notice, guys, at 30 degrees, our radian is pi 6. Do you see how at all the 30 degrees, the radian is pi 6? 30 degrees, pi 6. 30 degrees, pi 6. So just that kind of helps you kind of have a little cheat sheet. So we'll use that same idea here for 45 degrees. If we have a 45-degree right triangle here, once we get these obtuse angles or negative angles, we can always just recreate the right triangle of 45 degrees, no matter which quadrant, and then use that reference angle, root 2 over 2, root 2 over 2. 45 degrees should be a really easy XY point to memorize, by the way. And then all you have to take into consideration is, well, is my X and Y positive or negative, depending on the quadrant? So do you guys see how, now look, 45 degrees, do you see how like all the 45s, this is a distance of 45 degrees, 135, right? So 45 degrees would be our reference angle from 135 degrees. Notice how all the 45s end in 5s. It's kind of a little cheat to notice. Little things like that kind of help. So anytime I see a 5 at the end of my degrees, I'm like, oh, that's a 45-degree angle. Does that make sense? And so then I write down root 2 over 2, root 2 over 2. Then I just change my positives and negatives, X and Y points, depending on the quadrant. Okay, and then same with 60 degrees. So there's a distance of 60 from here to here, a distance from 60 to here to here. So 120 has a reference angle of 60 degrees. Does that kind of make sense, everyone? Doesn't 240 also have a reference angle of 60? Because there's a 60-degree distance from 240 to 180. So hopefully you're kind of seeing the idea here. All right, so let me fix this real quick. It's just bugging. This is side. Okay, look how easy this one is. It says, oh, yeah. There we go. It says, let negative 3, 4 be a point on the terminal side of angle theta. So let's go ahead and draw this in. We're going negative 3 units up 4 units, a rough sketch. Negative 3 up 4 units. Now, from there, we have a right triangle, don't we? So shouldn't I drop right down like this? Create a right triangle. Then from there, we will just, it just says find sine, cosine, tangent, cosecant, secant, cotangent. So from there, we'll just do Pythagorean theorem. 4 squared plus negative 3 squared equals hypotenuse squared. 25 equals hypotenuse squared. Our hypotenuse is 5. Will the hypotenuse ever be negative? No. So then from there, you'd say sine, I'm just going to write S because I'm being lazy. Sine of theta is equal to, oh, and theta should be where? Right there. Closest to the origin and x-axis always. So then opposite over hypotenuse, so 4/5. So then cosecant theta will be 5/4, won't it? So then cosine is, oh heck, another hour, so negative 3 over 5. Therefore, secant is equal to negative 5/3. And then tangent is equal to opposite over adjacent, 4 over negative 3. Therefore, cotangent of theta is equal to negative 3/4. Pretty easy. That's actually no different than what we saw last time. Now, why is that a reference angle? Because do you guys see how I dropped down? Instead of using this obtuse angle, I was using this acute one in the right triangle. Okay, let's read this one. It just gives us a little bit more information. It says, given that tangent of theta will be equal to negative 5/4 and our cosine of theta is greater than 0, it says, find sine of theta and secant of theta. All right. Now, here's what we have to talk about. I think I said this a little bit, maybe not exactly correct last hour. We got it right because our thinking was right, but I'm going to probably try to say this differently. So first of all, if we draw a right triangle in general, that's fine, but we have more information. We're going to have to draw it in the correct quadrant here in a second. So I'll just draw a triangle in general here. Here's theta. Our tangent is our opposite side over our adjacent side. So our opposite side is negative 5. Our adjacent side is 4. Does everybody agree? Now we can hurry and find our hypotenuse real quick. So that would be 4 squared plus negative 5 squared equals hypotenuse squared. So 25 plus 16 is 41 equals hypotenuse squared. So we have the square root of 41. Now the thing is we're told more information. We're told that the cosine will be greater than 0. Now what I did last hour is I said this. Cosine is x values. But is that true, or is that only true on the unit circle? Only true on the unit circle. So I said to them, I'm like, well, we can just say our x values are greater than 0, which it all worked out. But we kind of have to probably think a little bit more advancedly than that. So if the cosine is greater than 0, let's go down here and find cosine. So cosine is adjacent over hypotenuse. So isn't it all taken care of? Wouldn't that be positive as it is? Yeah. So we wouldn't need to put a negative here or anything. Okay, awesome. So then which quadrant would that fall in? Quadrant 4. Now here's why. Could we go negative 4 units? No. Isn't this our x, technically? So we can't go negative 4 units. We have to go this way. And then we have to have a negative 5. So it has to be down here. Our right triangle must be in quadrant 4. Our theta would go here. Now from here, drop incorrectly. So our opposite was negative 5, which makes sense. Down 5. Our adjacent was 4. Our hypotenuse is root 41. And now we can answer. Sine is opposite over hypotenuse. Negative 5 over root 41. So our sine is negative 5 root 41s over 41. And then our secant is the reciprocal of cosine. Now cosine of theta is another hour, so secant is hour another, or h over a. So our h over a would be root 41 over 4. Any questions on that? Okay. Good. So what if it would have said, well, we'll just keep going. Okay, so this one's straightforward. It says find the reference angle of 300 degrees. That means instead of 300 degrees, we need an acute angle that would be in the right triangle if I was to drop down and make a right triangle. What would our reference angle be? 60 degrees. Pretty straightforward stuff. All right, find the reference angle of negative 135 degrees. So what we would do is, here's my standard position. I would go negative 135 degrees. Here's negative 90, here's negative 180, so somewhere over here. Agreed? From here to here is negative 135 degrees. Now, where would we drop to? The 180, right? The x-axis, to create a acute right triangle. What would be the distance then of this theta? 45 degrees. Isn't there a distance from 180 and 135 of 45 degrees, everybody? Reference angles are always positive, so we'd say 45 degrees. So now look, I'm just pointing out that's your answer, but how useful would that be? So that's when you would say, in the future, you'd say, so I know since it's a 45 degree triangle, My point is root 2 over 2, root 2 over 2, and then because it's in quadrant 3, it's negative, negative, and now you can do trig on that without having to know the whole unit circle. Okay, that's how we'd use it. Okay, awesome. Find the reference angle of 2.3 radians. Now once again, guys, we can't get it scared away by a decimal radian. Remember, a decimal radian is just a radian that has pi already multiplied into it, correct? It's a distance, a physical distance of an arc. So right now, around our unit circle, we only have pi's. We haven't written out our decimal radians, but they're equivalent. So if I wanted to know the distance of 2 pi, or what the decimal radian of that is, we type in 2 times pi, which is 6.3 roughly radians. So going around a full circle would be 6.3 radians. So then what's the decimal radian of pi halves? You do pi divided by 2. It's what? 1.6. So 1.6 radians roughly. That's helpful. And then we know this one by heart. 3.14. Don't you guys always say pi is? Yeah, perfect. Let's just go here. Okay. And then what is 3 pi halves? Decimal radians. 4.7 radians. Okay. Well then let's just start drawing in what we're looking at here. So it says positive 2.3 radians, so don't we always start here at our initial side? We need to go 2.3 radian distance. So isn't this from here to here 1.6? This is 3.14, so it's somewhere over here. That is 2.3 radians in distance. Now to do a reference radian, don't we need to drop straight down to the x-axis, create a 90-degree triangle, and we want to know this theta as a radian distance. Isn't this going to be the finishing radius distance? Okay, how would we do that? 3.14 minus 2.3, that would be the remaining amount, which is 0.84 would be your reference radian. Okay, good. All right, so now it says this is going to be where we actually use this like religiously, and this is what's going to prepare you for calculus. So I really hope that this can like click in for you. And it's going to be really useful because we go way quicker once this clicks for us. Okay, so everybody, it says, find the cosine of 4 pi thirds. We are only going to use quadrant 1, and we're going to use that and then just kind of build on that. So first of all, doesn't it go like this? Pi 6, agreed? Pi fourths, and then pi thirds. Okay, so this is a pi third. Do you guys see? So it's going to contain, the reference angle is going to be the same as my pi thirds. So that is a 60-degree reference angle. Does everybody see what I'm saying? It will be the same xy point. Any pi thirds will have the same xy point as original pi thirds. We'll just change the x and y to be positive and negative accordingly. So now you'd say to yourself, what xy point goes with pi thirds? Hopefully we're getting it memorized. Anyone? Xy points. 1/2 and root 3 over 2. So then your next question would be, well, what quadrant does 4 pi thirds fall in? Now everybody, there's little tricks you can use. Wouldn't this definitely be 3 pi thirds? So then 4 pi thirds must be in quadrant 3. Do you guys see? So we'd say this is our xy point, but since we're in quadrant 3, negative x, negative y. Double negatives. So now from there you'd say cosine is the x. So our answer is negative 1/2. Then you only have to know quadrant 1. Hopefully that helps. Does anyone have any questions? So important to be able to do. Okay, let's do another one. Now what if, okay guys, let's say you got to the test. I always have people like, it blows my mind. They get to the test and it says, use reference angles to find tangent of negative 210. And they go, well, I don't know what a reference angle is, so I can't do it. Well, could you do it with the unit circle? Yes. It's just, we're learning another way to do it. Does that make sense? So if you were desperate and you didn't know how to use reference angles, couldn't you just go to negative 210 on your unit circle and still get the answer right? We're just learning this to have another method to go quicker and to be better for calculus. Okay. Okay, so use reference angles to find tangent of negative 210 degrees. So I would just start out like say, well, what reference angle would that be? So here's 0, negative 210 somewhere over here, agreed? Negative 210, my reference angle will be this angle. What would be the distance? Oh yeah, I didn't go far enough. I did not go even close to far enough. You're making a good point. It's actually like this somewhere.
There we go.
Okay. So then we drop down 90 degrees. Okay, what would be the distance then? This is 30 degrees. Okay, so you'd say my reference angle is 30 degrees. At 30 degrees, my xy point is root 3 over 2, comma, 1/2. Agreed? Then from there, you'd say because we're in quadrant 2, it's negative x. And then our tangent at that would be y over x. 1/2 over negative root 3 over 2. Dividing fractions easy as pie. Flip the second, multiply. Unless you have your tangents memorized, then our life's even easier. What is it? Yep, negative root 3 over 3. That would be what it's simplified to be if you have that memorized. Good. At 30 degrees, our tangent will always be root 3 over 3. And then it will just be positive or negative depending. Good. Very good. You guys are awesome. What's the tangent at 60? Square root of 3. And then what's the tangent at 45's? 1. You guys are so good. You guys are going to be so ready for calculus. I can't wait for the teacher to come praise me. All right. Yeah, I know, right?
Just for the break.
Right. So cosecant of 11 pi fourths. Now, guys, people tend to really overthink this. Here's what I would notice. Isn't it a pi fourth? Yeah. So my reference angle, we automatically know will be a 45 degrees. Because isn't that the pi fourth thing every time? So you'd say my xy point is root 2 over 2, root 2 over 2. Then from there, you'd say, I do need to know what quadrant 11 pi fourths would be in.
It's the fourth quadrant and fourth one. Yeah. No.
There's a lot of ways we can do it. We can find a coterminal angle, yeah? But even, there's other ways to do it. So this is kind of what I was thinking. Right here is 8 pi fourths. Isn't this 8 pi fourths?
Yeah.
So 8 pi fourths, and then right here would be 9 pi fourths, 10 pi fourths. So 11 pi fourths is in quadrant 2. But there's so many ways to do that. That's not the only way. Couldn't you find a coterminal angle by subtracting 2 pi, everybody? But that's just how I did it. So quadrant 2 has negative x, positive y. So then the cosecant is the reciprocal of sine. Cosine's x, sine is y. There's our sine. So our cosecant would be, let's do 2 over root 2 just so people can see it. And then you'd rationalize the denominator. So root 2, root 2. 2 root 2's over 2, a.k.a. root 2. Awesome. We love reference angles. It makes our life so much easier when we don't have a unit circle in front of us. And you won't in real life when you get to calculus. That's the end of the lesson. The rest of the time's yours to practice.